Okay, so when we're looking at the volume of rotation of the solids, a couple of little tricky tricks to be careful of. First thing you need to do is make sure that you know which axis it's being rotated around. So this one is telling us that it's going to be rotated around the y-axis. So I'm going to go to my formula book and I'm going to look for the formula for the volume of this rotation. So V is equal to pi between B and A for our function f y squared dy. Okay, so here you can see that our function's in terms of y. Now, both up here we've got our functions in terms of x, or y equals some form of x. So the first thing I'm going to do is I'm going to rearrange those two equations. So the first one will be y equals 4x, which means that x is equal to y over 4. The next one is y is equal to 2x squared, which means that x is equal to y over 2 and square root that whole thing. Or you could say it's to the power of a half, either or, whatever tickles your pickle. All right, so that's what I found so far. Now, to help me wrap my head around this question, I'm just going to quickly knock up a little drawing. So if I draw the line of y equals 4x, the linear line that passes through our origin there, so 0. Now, if I draw this other line, y equals 2x squared, that means that it's going to also, because there's no c component, it's going to pass through the center at 0, 0. So it's going to look something like this because it's going to be a happy face. Whee! So the area that it's asking to rotate is this area inside here. Now, to find out what parts I want to rotate around, we already know A is going to be 0. I want this value here. This is going to be B. This is A, this is B. Okay, so different ways you can do this. How about we just let the x's equal each other? So y over 4 is equal to square root of y over 2. Take the squared over, or the square root will square everything on the other side, meaning that this is going to become y squared over 16. Let's just escape this so I can move down. Okay, so y squared over 16. Now I'm going to take this to the other side as well. So minus y over 2 is equal to 0. Next thing that I'm going to do, to try and make my life easier, I'm going to make these have the same denominator. So I'm going to scale this one up by multiplying the top and the bottom by 8. Y squared over 16 minus 8y 16 equals 0. Now they're both over the same denominator. I can take the 16 to the other side. So I'll be left with y squared minus 8y is equal to 16 times 0 is 0. Now I can factorise this expression. So y can come out and I'll be left with y minus 8 equals 0, meaning that when I use null factor rule, I'll have y equals 0, y minus 8 equals 0, so y equals 0, and y equals 8. Now, the other way of solving this, the probably way more popular way of doing it, would be how you normally do it. You get your functions here, you let them equal, you find your x-intercepts, and then you just replace it in terms of the other one. But, you know, tomato, tomato, potato, potato. So now I found out that I've got A and I've got B. So next thing I need to do is I need to think about which of these functions is going to be on top when I go to integrate it. So I'm just going to do a little squiggle. Just give myself some space. Okay, so here's what I've got so far. Volume is going to be equal to pi integrate between 0 and 8. Now, remember, this is going to be composite shapes, so I'm going to have the big function minus the little function. Okay, so if I'm rotating this around this axis, and you think about turning your head, so you're looking at which one's on top here, this equation here, parabola, is going to be on top, this one's going to be on bottom. If I do that curvy one, and then that would give me all this area in here, and then I subtract that triangular one there, that's going to leave me with that little portion of the overlap. So that's how I know which one's going where. So that one's on top. So that's going to be y over 2 squared and y over 4 squared. Now, these in here are each squared because when you're squaring it, you're applying like the area thing to it. So you don't want to create one function and then integrate it that way. You want to keep them as two separate functions, square them both, and then integrate those answers. So pi 80. So when this squares, it'll just get rid of that horrible surd symbol. Okay, and now it looks like a nice function that we're ready to integrate. So y squared over 4 minus y to the power of 3 over 16 times 3 is 48. If you don't believe me, you can do the maths. Now we're going to substitute in 8 and 0. So 8 squared is 64 divided by 4. That's going to be, 4 goes into 60 10 times, 24 remaining, so that's going to be 16 for that one, minus 8 cubed, 64 times 8, to be, okay, so 512 over 48. And that's going to all minus 0, because as soon as I put 0 into these ones, they're just going to vanish. Okay, so next thing that I'm going to do, that one divides down to have nice numbers. That's even, that's even. Let's just halve them and see what happens. So 500 divided by 2 will make 250. So 256 over 24, even again, so let's halve them again. So 250 divided by 2 is 125 plus the 3 will be 128 over 12. This is good. Halve them again. 12 will be 64 over 6. Good. Still even. Halve them again. So that'll be 32 over 3. So minus 32 over 3. Okay, so we want to keep going because we're still not at our simplest form. So pi. So if I do 16 times 3, that'll make them both have the same base. So let's do that. So 16 times 3 is going to be 48. So 48 minus 32. It's going to be 16 over 3, and that's pi left on the end. Now, they didn't put it, but it should be units cubed here. Now, if you're thinking about where they would give you marks for this, I did look at the marks guide. You get 1 mark for the final answer, 1 mark for it being logical, which is something I haven't seen before. Very interesting there. You get 1 mark for expressing or finding these intercepts. So 1 mark for that, 1 mark for that. You get 1 mark for expressing these in terms of x equals instead of y equals. 1 mark for determining this, and then solving it gets an extra mark, so that's a freebie. Putting it all in gets you a mark, and then I think that's about it. So 7 marks in total.